Okay, so we are working with the homework problems. It is a punter on a football team tries to kick a football so that it stays in the air for a long hang time. If the ball is kicked with an initial velocity of 25 meters per second at an angle of 60 degrees above horizontal, let's calculate the hang time. So essentially this is what we have. So we have this projectile path that is launched at a 60-degree angle, and it is done so with the velocity of 25 meters per second. So a couple of things. In order to calculate hang time, what we have to determine is the time it takes for this projectile to essentially start here. We're going to call this part A, and remember B is the middle and C is at the very end. So at part A, what's occurring, at part C, what's occurring, and then A is going to be our initial, C will be our final. Alright, so let's kind of start there, right? So what are our knowns? What are our unknowns? And we'll start there. So, okay, so remember, we always break this down into X and Y for knowns and unknowns. So in the X direction, right, I know that the acceleration in the X direction is always going to be 0 meters per second squared. I know that the initial velocity in the X direction is going to be found using SOHCAHTOA. Now, the way you find that is 25 cosine of 60 degrees. Right, so remember, you have this triangle. I'm just going to draw it out to the side, where this component is, so the horizontal component is VIX, the vertical component is VIY, and then you kind of solve this in that manner. So this is 25, adjacent, you use cosine, opposite, you use sine, you go from there. So VIX is 25 cosine of 60, VFX is also 25 cosine of 60, since acceleration is 0. Now we don't know time, that's actually what we're looking for, and then distance in the X direction we also don't know. Now talking about the Y, we know that the acceleration in the Y is negative 9.8, that is true for all projectiles. Initial velocity in the Y direction will be 25 sine of 60 degrees. The final velocity, VFY, is negative 25 sine of 60 degrees. And then time is actually what we're looking for. And then displacement in the Y, that is 0 meters. It starts here, travels some distance, comes to 0 meters per second, and then comes back down. So its actual displacement in the vertical direction is 0. Good. All right, so here's our knowns and unknowns. What you can notice here, you have 3 knowns in the X, you have 3 knowns in the Y. However, if you try to solve this in the X direction, you will not be able to solve for time. You can try it. You'll find multiple ways of how not to do it. So solve this in the Y, right? This is really how you get to these types of problems. So solving this in the Y, the equation that we use using acceleration, initial velocity, final velocity, and time is this equation. So the equation we actually use is final velocity is equal to initial velocity plus acceleration times time. Final velocity in this case is a negative 25 sine of 60. Now that becomes, if you solve for that, it's actually negative 21.6 is equal to 21.6 plus the acceleration, which is negative 9.8 times time. Now here we can solve for time. So you subtract by 21.6, subtract by 21.6, you get 43.2 is equal to negative 9.8 times t divided by negative 9.8. Sorry, that should have been negative. Divided by negative 9.8, divided by negative 9.8, and you are left with time is equal to 4.42